All right, folks, these are the video answers to the rounding up and down circuit worksheet. So, problem number one says you've got as many 3-volt batteries as you want, I guess, and a 15 ohm floodlight. And so we're looking for how many of these 3-volt batteries you need to connect to produce at least 1.7 amps. Okay, so the big formula we're going to use over and over again in this unit is Ohm's law. So current equals voltage over resistance. There's only one resistor, so we don't have to worry about that, but we could have as many 3-volt batteries as we want. So I call that N for number of batteries. Does that make sense? So if we had one, N would be 1, and we'd have 3 volts. If I had 2, N would be 2, and I'd have 2 times 3, or 6 volts. Okay, so this is just easier saying N times V instead of saying 3 plus 3 plus 3 plus 3 plus 3, trial and error. Okay, so that's the skill that I think is important. Okay, so the current is some number of batteries divided by the resistance. And we want I to be 1.7 amps, and that's going to be N times 3 volts over 15 ohms. And then you can solve this. You could take 3 divided by 15. You could do this a couple of different ways. You'll get the same thing. I decided to put this over 1, and then we're going to cross multiply. So 1.7 times 15 is 25.5 equals N times 3. And then I'm going to divide both sides by 3. And so the number of batteries you get is 8.5. And this doesn't have units because it's a number. All right, so if I wanted 1.7 amps perfectly, that's why we use the power supplies, right? I could dial that power supply to 8.5. Sorry, that's not 8.5. Whatever 8.5 times 3 is. I could dial it to that voltage. But I don't. I have discrete 3-volt batteries. So you don't want to use the rounding rules of 0.5 and above rounds up. What you want to do is think about whether you want the current. The current can't be 1.7 perfect because you can't have a half of a battery. So you're either going to need to round up or round down. So you want to think about, do I want the current to be a little bit over 1.7 amps or a little below 1.7 amps? Okay, and that's reading the problem. That's not mathematical. So if we want it to be at least 1.7 amps, that means we want to err on the side of more energy. So more energy means rounding up to 9. So I want 9 batteries to get at least 1.7 amps. Okay, don't memorize that at least always means rounding up, because this is true when you're talking about getting more batteries, but it would be the opposite if you were talking about getting more light bulbs. Okay, so please don't memorize that. Use logic to figure out whether you want to round down or up. Okay, so we want 9 batteries. But what's a little bit challenging then is, I know it's a little bit annoying, but that's the real world. You're not going to get 1.7 amps. So we want to know, what kind of current are you going to get? So the current you're going to get is number of batteries times the voltage over number of resistors. I think I call that X times the resistance. Okay. So we don't know what I is. It should be close to 1.7. It should be more than 1.7. We decided N was 9. So we want 9 3-volt batteries. And we're going to divide by 1 15-ohm light bulb. So you get 27 volts over 15 ohms. And that is 1.8 amps. Okay, so again, in the real world, you're not always going to get, we wanted 1.7 at least to be bright enough, and we got 1.8. We had to overshoot because, it's like when you go to the ATM machine, you can only get $20 bills out of it, right? So sometimes you have to round, you want to make sure you have enough money, so you're going to round up. All right, that was question 1. All right, then Jalen finds a whole bunch more 3-volt batteries and a 40 ohm crepe maker. But he doesn't want to burn the crepes. So he knows the crepe maker is supposed to have 0.8 of an amp, but he wants to undershoot this time because he doesn't want to burn the crepes. Okay, so the current is going to be N times V over X times R. We want close to 0.8 amps, 8 amps or below, 0.8. And we have N number of 3-volt batteries and a single 40 ohm crepe maker. And so again, I cross multiplied. .8 times 40 is 32 ohms. 3N times 1 is 3N. And then we're going to divide by 3 and divide by 3, and you get N equals 10.7. So because this had more resistance, I need more batteries, and I'm actually going to get less current. Because remember, resistance means this is taking energy away. So this is taking more energy away than the light bulbs were. Okay, so I need 10.7. The rules of rounding would tell you that you want to round up to 11. But if you round up to 11, because this is energy, you're rounding up the energy, you're going to have too much current. So you want to round down to 10 to make sure that you don't have too much current. All right, and then we're going to check our work by calculating the actual current. It's not going to be 0.8 because we had to round. So the current's going to be NV over X times R. I have 10 of these 3-volt batteries and a single 40 ohm crepe maker. So 30 volts over 40 ohms is 0.75. Amps. Yay. So that is less than 0.8. So we're doing okay. All right. Problem number 3. Now we're going to keep the voltage the same and add light bulbs. So he decides he's got an 80-volt battery, and he wants to give everybody like an electric blanket. Each electric blanket is 7 ohms. But if he doesn't have enough current going through these, then they won't be warm enough. So he wants at least 2.5 amps. So I is going to be N times V, but we know N is 1 because there's only one of them, over X times R, and that's what we're solving for, is X this time. Okay, so he wants at least 2.5 amps, and that's going to be 80 volts over X times 7 ohms. And we want to solve for X. And so that gets a little bit trickier because you're trying to solve for something in the denominator. So, but algebraically, we're still going to, try to isolate X and figure out what it is. So we get 80 times 1 is 80. And then 2.5 times 7 is 17.5 X. All right, and then divide both sides by 17.5 so we can isolate X. And we get X equals 80 over 17.5, or 4.57 heaters. Okay, but we can't have 57% of an electric blanket, right? We got to decide whether they're going to round up or down. So the last two we did, we were talking about energy. So if we increase the voltage, we get more current. If we decrease the voltage, we get less current. Now we're talking about adding or subtracting resistors. So again, the rules of rounding would say round up to 5. But if we add too many resistors, remember, if we add more and more light bulbs, they're going to get dimmer, right? Because each one of these is taking energy away from the electrons. And we want at least 2.5 amps. So if we round up, that's going to reduce the current. So we need to round down, otherwise the current will be too low. So we want to round down to make sure we get at least 2.5. So that means we want 4. Okay, and then if you're not sure, especially because the resistor might be a little bit trickier because it's an inverse relationship, check your work. Let's find the current. That's what this question is for. So I is going to be NV over X times R, and we only have one battery, so that's 80 volts. And we decided we wanted 4 of the 7 ohm electric blankets or space heaters. So that's 80 over 28, which is 2.86 amps. Yay. So we have enough current to generate heat. But if we had rounded up to 5, this number would have been less than 2.5, and then we would have known we rounded the wrong way. Okay, this is the last question, so thank you for hanging in there. All right, so now he wants to wire up, again, keeping the battery constant, and he wants to add a bunch of light bulbs, but as he continues to add light bulbs, the current is going to dim. So I'll do this up here. So I equals NV over X times R. We want the current to be less than 0.5 amps. Otherwise, they're too bright, and the sea turtles think they're the moon. He has a single, so one 44-volt battery, and he wants to know how many 13-ohm lights he needs. So we're solving for X. Okay. So cross multiply. And so 0.5 times 13 is 6.5 X, and then 44 times 1 is 44, and then divide both sides by 6.5 and divide by 6.5, and you get X equals 44 over 6.5, or 6.77. But you can't get 77% of a light bulb. You either get 1 or none. So let's think about whether we want to round up or down. He wants to make sure that the current isn't too bright. So if we rounded down, it would be too bright. We want to round up to increase the resistance so the lights are not too bright. So we want to round up. And so what we want is 7 total light bulbs. And then you can see on I'm copying my my PDF answers. It didn't ask you to find the current, but let's just do it one more time just to check our work to make sure that we have less than 0.5 amp. So I is number of batteries divided total voltage divided by total resistance. And we have one 44-volt battery, and we have 7 13-ohm light bulbs. So 44 volts over, I don't know what 7 times 13 is. 91 over 91 ohms gives you almost 0.5 amp. Okay, which is less than 0.5. So yay, we did not cause the baby turtles to get lost. All right, that was the rounding up, rounding down worksheet. I just think that's a little bit more interesting problem solving than just dividing V by R over and over again. So hope that went well, and I will see you in class.